This is the second video on chapter 42, solids of revolution and surface area. And for this example, example 252, this is part A. But the first part of example 252, I'm going to do problem 10 from page 595 from our textbook. The function we're given is the square root of the quantity 1 plus e to the x. X ranges from 0 to 1. And as with the previous example, we will integrate this expression. So we'll integrate from 0 to 1 of 2 pi y, derivative of y squared plus 1, the square root of this whole quantity. So we calculate the derivative. That's just a matter of using the power rule and the chain rule. So we have 1 plus e to the x to the 1/2 power. Take the derivative. We have 1/2 times 1 plus e to the x to the negative 1/2 power. Then we multiply by the derivative of 1 plus e to the x, which is e to the x. So we take this expression and we substitute. So we have 2 pi y. Then we have this is y prime squared right here, plus 1 under the square root. From this step to this step is algebra. Because this is honors calculus 2 and not an algebra class, I will not go through the steps in detail. I will say that what you do is you find a common denominator here. This denominator will simplify with this expression outside the denominator, or outside the square root, rather nicely. And there's more to do, but it simplifies to this. If you're having trouble getting from this step to this step, ask me in class and I will go over that with you in more detail. So we integrate this expression. We just have an exponential function plus a constant. Finding an antiderivative is not very difficult. Then we substitute 1 and we substitute 0 and we subtract. And it simplifies to pi times e plus 1.